We made it. It's the final lesson. Binomial expansion. All right, so let's get on with it. Binomial expansion means we're going to be given a binomial and we have to expand it. So over here you have a binomial. X plus y raised to the 0 power. That's easy to do. Anything raised to the 0 power is 1. I'm going to take that same binomial and raise it to the first power. Again, that's easy. Anything raised to the first power is itself. You guessed it. We're going to keep the expansion going on, and we're going to take x plus y, and we're going to raise it to the second power. It's expansion. In other words, what do we get when we take x plus y and multiply it by x plus y? We expand it, and we get x squared plus 2xy plus y squared. Now we're going to raise it to the third power. So that means I have x plus y times x plus y times one more x plus y. And when we multiply that out, we expand it out, we get this. And then to the fourth power. So for those of you who may have noticed something, there are so many patterns going on here. It's like obsessively great. Sheldon Cooper would be having a field day. First off, if anybody noticed, it's Pascal's triangle, right here. Notice 1, 1. My next row has two terms, but look at their coefficients. Coefficient of 1, coefficient of 1. Look at my third line. Coefficient of 1, coefficient of 2, coefficient of 1. 1, 3, 3, 1. 1, 4, 6, 4, 1. All right, before we do that last line, let's find some more patterns. Look at the exponents. Let's look at the exponents of x. 3, 2, 1, none. Let's look at the exponents of y. None, 1, 2, 3. If I look at the y's here, none, 1, 2, 3, 4. So they go up in order. And my x's go down. 4, 3, 2, 1, none. So if I wanted to do this expansion of one more row, x plus y raised to the fifth power. Well, the first thing I'm going to do is come over here and use my Pascal's triangle. So I know I have a coefficient of 1, of 5, of 10, of 10, of 5, and a 1. The next pattern I saw was each one, xy, 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 xy. I could put xy, 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 and now I can just do my pattern. Alright, I noticed that my x's start the game. And since this started with x to the fourth, that's because this was raised to the fourth power. This started with x to the third because it was raised to the third power. This started with x squared because it started x to the second. So this is going to be x to the fifth. Then this will be to the fourth. This will be to the third. This will be to the second. This will be to the first. This would be to the 0 power, but x to the 0 power is 1. So I can get rid of that. Now I'm going to do my y's. My y's go up. 0, 1, 2, 3, 4, 5. And once again, anything to the 0 power is 1. So I can get rid of this. Technically, I don't need my coefficients of 1. And there, I just expanded. X to the fifth plus 5x to the fourth y to the second plus 10x cubed y to the second plus 10x squared y to the third plus 5x to the first y to the fourth plus y to the fifth. And if you noticed one last pattern, every set of exponents has to add up to the power that I raised it to. So in other words, 3 plus 1 is 4. 2 plus 2, 4. 3 plus 1, 4. So down here I can check myself. 5. 4 plus 1 is 5. 3 plus 2 is 5. 2 plus 3 is 5. 4 plus 1 is 5. And 5. There we have it. Binomial expansion. Now, on the Regents, they're going to give you your formula. It's called the binomial theorem. And look at that. That just looks like one big utter mess. But notice what they did. They did the same thing we did. Here is Pascal's triangle. N objects, I don't choose any of them. N objects, I choose one of them. N objects, I choose two of them. And then I go down until I match what exponent I was raising it to. Then I start with my first, like I started with x, goes x. Now I go down, 1 less, 2 less, 3 until I have none of them left. And my y's, remember my y's, they went up. In the first one I had none, then I had 1, then I had 2, and they go up until I meet n again. Also, this looks like the probability that we were doing for the past two. I have my combination out front, my losing probability n minus r, and my winning probability r. They all kind of look the same. Alright, so let's say I wanted to expand this. First things first, I know it's expanded to the fourth power. So what I'm going to do is I'm going to set myself up. I know it's Pascal's triangle. 4C0, 4C1, 4C2, 4C3, and 4C4. And that's why I like using Pascal's triangle and not using the calculator, because I could have just come over here and I could have taken Pascal's triangle and instead of writing that out, I could have just gone to this line and know that I have 1, 4, 6, 4, 1. And I'm giving myself some spaces because now the next part, my expansion, I had to work with my x's. So my x in this case happens to be 2x. 2x, 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 and 2x. Following all those patterns I found, when I expanded something, let's clean this up so you can see it better. When I expanded something that was raised to a power, the x's went down. Start with the highest and then go all the way down. All right, so my highest here is 4, so this would be raised to the 4th power, to the 3rd, to the 2, to the 1, to the none. Now I'm going to put in my y's. My y here is just the number 3. And y's go backwards. So this would have to be 0, 1, 2, 3, 4. Now the rest is math. Just figure this all out. 2x to the 4th power is 2 to the 4th is 16, x to the 4th. And then done. When I figure this out, got a little more math to do here. 4 times 2 to the 3rd power is 8. X to the 3rd power is 8x cubed. 3 times 1 is 3. So 32 times 3 is 96 x cubed. And there must be a plus sign in between because they're all positive. 6 times 4x squared and 9. Well, 24 times 9 is 216 x squared. It's a plus, so it's positive. 2x to the 1st power is 2x times 4. 3 cubed is 27. So what's 54 times 4? 216 again. Plus, and then my last one, well, this one's not bad. 1, anything to 0 power is 1. 3 to the 4th power is 81. So in other words, if I were to expand this out by hand and multiply it all the way out, that's what I would get. Now notice we still have some patterns going on here. We still have our x's going down, 4, 3, 2, 1, none. But since we didn't have a y, we have no patterns with the y's because they got incorporated as numbers. And the 1, 4, 6, 4, 1 doesn't stand out because we had some coefficients that got multiplied into it. Find the 5th term of x minus 2 raised to the 15th power. Wait a second. 15th power? Are you kidding me? My God, look at all the work I had to do and I just raised it to the 4th power. Oh, but wait, it didn't say, wait, this one said expand. This one doesn't say expand, it says it only wants one term. Oh, that's so easy. So if I think about it, 15C0 is the first term, right? We learned that back here. See how the first term was the 0? 15C1 would be the second term. Look for the pattern. 15C2 would be the third term. I think I see the pattern. So I bet you 15C4 would be the 5th term. See, because we had the 0 in here, we always do one less than the term they ask for. All All right, so that means all I have to do is find this one, 15C4. Perfect. C4. My x value and my y value. Careful, my y value is a -2. All right, so what are my powers? Well, again, 15C4, x would be being raised to, if we count down, the first term would be raised x to the 15th, x to the 14th, x to the 13th, x to the 12, x to the 11, x to the 10. Get it? First term, the second term, the third term, the fourth term. Oops, the fifth term. I went too far. So this would be 11. And then what would this be? Well, this would have to be 4, because 11 plus 4 gets me 15. Or the easy way to remember it, see how this is a 4? That's a 4, because that's how we did it in the probability. See the R right there? It matched over here. See this? The 0 matches here. The 1 matches here. So again, this is full of patterns. Sorry, full of patterns. You just have to figure them out. All right, so 15C4, I'd pull out my calculator and do 15C4. So let me do it here. 15 is 1,365. X to the 11th is easy. It's x to the 11th. And negative 2 to the 4th power is going to be a positive 16. Because remember, when you raise a negative to an even power, it's positive. So my final answer is 1,365 times 16. The fifth term would be that right there. Goodbye.